Welcome to Engineering Scale Models. I'm Jason, your host. I do models and electronics. What's up with that? Hopefully I can teach you a little something today. This is not an in-depth episode. This is just an overview of the diode. Diodes, what are they? Well, they're a device that can allow current to pass only one way. Unless you're a little crazy and use a Zener diode, and then current can go both ways at a point, and current can go both ways. So, there's that. But let's talk about the basic diode first. Let me get this out of the way, and we will talk about a regular diode. Let's talk about a diode. Let's talk about the schematic symbol first. So we have a triangle with a line and another line coming out of here. Here is your anode, and here is your cathode. This will be your more positive voltage, and this will be your more negative voltage. And a good way I remember this now in the time of the pandemic is AN is positive with coronavirus and CAT is negative for coronavirus. Anode positive, cathode negative. So that is your diagram for a diode. Then you also have a Zener diode, and I've seen these drawn a couple different ways. That's how I draw it. Oops. Oh, I did. That's how I draw it. With the little wingy things on there. And again, this is your anode, your positive, and your cathode, your negative. And with a Zener diode, or with a regular diode, current can only flow this way. With a Zener diode, current can only flow this way until a voltage is present. And then once a voltage is present, the Zener voltage will backfeed, and then you can use it in a circuit to cap off a voltage, and I will talk about that in a minute here. Let's clear this off here, and let's talk about diodes in some circuits. One of the most common diode that most people think of is a bridge rectifier, and a bridge rectifier uses 4 diodes. Let's draw the 4 diodes here, and then with that, the 4 diodes always point to positive. I believe I'm drawing this correctly. So, and then right here you would have your ACN, and right here you would have your ACN, and then out here you would have your positive, and out here you would have your negative on your rail. And what happens is, as the sine wave is on its positive side, so if you have your graph here and your sine wave is on its positive side, the current will flow through here and out through your positive, back through your negative, and into the other side of the sine wave. When you have the other side of the sine wave, it will flow in this way through the positive and back through the negative and out that way on the other side, and then it will go vice versa. So using the diode in a one-way, using it so voltage can only pass in one direction, or current can only pass in one direction, you can turn in a sine wave into a flat DC current. But it's not technically a flat current. Basically what you're doing is you're flipping the wave, so you would end up more like this with a bridge rectifier, and then you would need smoothing caps and all that stuff. This is just about diodes. So that is diodes as a bridge rectifier. Let's go here and let's talk about you can also use one diode. You can use a diode as a backfeed for an inductor to prevent the backfeed when a magnetic field collapses in a coil. So if you have a coil here and you have a coil here, and you have a coil, and if you put a diode in the circuit, basically what happens is current will flow through this way and around this way, and then it'll create a magnetic field in inducing a current into this coil. But what happens is when the current is when this is turned off, this magnetic field collapses. It induces a current into this one, but the diode will prevent it from going back through the circuit. Now there's other components that are involved on that, so this is just a basic overview of a backfeed diode, how a backfeed prevention diode would work. And then we have our Zener diode. So our Zener diode, the most common way I can explain to use this is if you have a Zener diode in this arrangement here, and it is a 12 volt Zener diode, and then you have a resistor, pardon my drawing, and you have negative here and you have positive here, and you have a tap off of here. If you put in 20 volts here, this Zener diode will clip it off and you'll have 12 volts on your output. So the Zener diode will allow the 4 volts, it'll drop the 4 volts. So across the diode you would have a 4 volt drop. So speaking of drops, let's talk about a diode. Your normal standard diode that I will show you will have a voltage drop of about 0.6 volts. You can get them in Schottky diodes that have a lower voltage drop, but about 0.6 volts of cross voltage drop. Like I said, a Zener in reversed direction will drop more voltage. Make sure you stick with the rating of the diode, and be sure you use the right current rating for a diode and all that good stuff. But let's take a look at some diodes. So here I have some diodes here. I joined these together for an experiment in a live stream, but this is a typical diode. It has a band on it. The band is the negative side, so think of it as the flat line in the drawing. So that is your cathode and this side is your anode, and basically current will only flow in one direction. And if we undo these here and I put them across my meter, we will take a look here. Let's bring up the meter, because of course I wasn't prepared and I didn't load the meter, but we're going to do it. Only take a second. Let's do this, and we're going to put it in diode mode, and we are going to turn the scope, the meter. Oh, there it is. It was there the whole time. Look at that. So right now it's reading open circuit, and I am going to put my lead, I'm going to put my positive lead on the anode, and I'm going to put my negative on the cathode. It will beep, but as you can see, there is a 0.6 voltage drop across the diode. But if I reverse my probes here and I come across this side, there's nothing happened. It considers it an open circuit because it will not allow the circuit to pass through. So this is a axial through hole component. There are surface mount diodes. Here is an assortment of Zeners and just various diodes of different ratings and things like that. This is my surface mount for fixing consoles or whatever electronics I may get. It's got a nice little thing. There is silicone rectifiers, fast recovery, ultra fast recovery, super fast recovery, Schottky, high speed switching, and more Schottky. So then you got some SOP 23s that are sometimes two diodes in one. I could probably show you a diode on a circuit board here. I know there's one on this circuit board. There we go. Let me pull this up here, and I'm just going to zoom in here. This is going to be a Nintendo switchboard. I'm just zooming in a little bit closer. And this Nintendo does an interesting thing with their... There we go. So there you go. This right here is a diode right here. It is super tiny. If I show you on this camera, it is right there. But on the microscope, it's a little bit bigger, and you can see that it actually tells you the orientation of the diode. So that is a surface mount diode. I'm not sure that looks like it's part of the LCD circuit. We also have this could be a diode here also, and it does tell us the orientation if you have to replace it. You can buy the diodes on DigiKey. There's different ones. These right here, let's see if we can take a look to see what this is. This should be a 1N something. Yeah, 1N 4001 4007. Okay, well, thought I had it. 007. That's a pretty standard diode. I have in my assortment of components. I have quite a few of those. I even have a few Zener diodes. I can show you a through-hole component Zener diode. They're a glass diode here. This is a Zener diode there. So these actually have numbers on them, so you can tell what they are. So that's actually a Zener diode. But there's different types of combinations also on this board. Let's show you the one on the back right here. This little chip right here is a diode array. I've never heard of a diode array until a few weeks ago when someone pointed out that's what these are. Pulled them up and on the data sheet on them, and it's a very interesting diode array of what's inside. They only showed a block diagram, but it's two diodes that are joined together at the cathode, and then one side passes through the anode through both cathodes. So I'm not 100% sure. I don't know if they're using Zener diodes or what. There's not a whole lot on the data sheet on how it works, but it was a pretty interesting find. But that is my basic overview of a diode. They allow current to pass in one direction and not the other direction unless you have a Zener diode. So that is going to do it for this video. Here are the links to social media. I've been posting a little bit more, not as much as I would like to. You could also visit my Patreon website. There is stuff up there free, no need to sign up. But if you do choose to sign up, that would be greatly appreciated. I plan on a lot more of these basic electronics series in the future. But thank you so much for watching, and I hope you guys have a fantastic day. Thank you.